Now let's start our discussion on the smart metering. We'll understand why the conventional meter doesn't help in better monitoring and control of the load, and we will also try to understand what smart meter offers to the customer. Now, before going into the details, let's first try to see the history of conventional energy meters. So, first generation of the metering started in 1851, where we saw first gas meter. Then in 1872, first electric meter was invented. In 1889, the first spinning disk power meter, so that you can see here, we see in the conventional meter we have in the center as spinning disk. So that meter was developed in 1889. So you can see that what conventional meter we used to have in our houses say 10 years back, where we were having one spinning disk, those were developed around 100 years back. Now in 1980s, we saw first solid state or the digital meter in the market. In 1990s, we saw first AMR, and from 2009 onwards, we are seeing the smart meters which are having two-way communication. The features which we see in the conventional meters, it contains dials to show the energy usage information. The energy usage is read manually from the meter. Energy usage over a large time period, generally the monthly, is captured from the meter for billing. Limited measurement quantities, that is mostly real power consumption informations, are displayed in the conventional meters. Simple non-programmable instrument, because here the programming capability is not built in the meter. Conventional energy meter has certain disadvantages. So what are those disadvantages? It is difficult to get the frequent energy consumption information because of having manual reading capability. We cannot take data more frequently. Mostly we take monthly data for billing purpose only. It does not support multiple tariff. If the utility wants to implement time of use tariff, the analog meter doesn't have that capability to address the time of use tariff. It cannot be monitored and controlled remotely. It cannot be programmed to display the derived quantities such as power factor, kVA consumption, because it is a non-programmable instrument. It does not provide consumption pattern over a period because we cannot take frequent energy consumption data. And it is non-interactive because it doesn't have any two-way communication. Now let's talk about the smart meter. So let's see the history of a smart meter. So in 1972, Theodore Paraskevakos developed a sensor monitoring system that used digital transmission for security, fire, and meter reading capabilities. So this technology was spun off from the automatic telephone line identification system, which is commonly known as caller ID. So what the technology we used to have in the basic phones for caller ID purpose, the same technology was utilized to develop the sensor monitoring system for digital information transmission. Now in 1977, he launched MeterTech Inc., which later developed first fully automated commercially available remote meter reading and load management system. So this can be considered as a starting point of smart meter technology development. Now smart meter features, it has an electronic digital display that flashes different measurement quantities in sequence. It can be programmed to get the derived measurements, can be monitored and controlled remotely because it has the bidirectional communication. No manual data reading is required because data can be sent automatically from meter to the remote server. Loss of power or restoration notification is available in the meter. It can transmit required information in short intervals. You can say nearly real time over the network. Generally, we take data from the smart meter after every 15 minutes. This we will discuss when we will discuss the advanced metering infrastructure. But you can configure the smart meter to send data after every say 10 second or 30 second also. But this requires huge data bandwidth, which is again a bottleneck in the current scenario. Now let's talk about the various features of a smart meter. It provides 4-quadrant metering as well as net metering. What is 4-quadrant metering? 4-quadrant metering means it can give you the real and reactive power import as well as export in a separate measurement. So that means we can get 4 measurements from the meters where real power and reactive power import as well as real power and reactive power export can be measured. Now, why it is required? Because sometimes we might have the solar PV installation in the houses, and during lightly loaded condition, energy needs to be exported back to the grid. So in that scenario, the smart meter should have the capability to individually monitor the import of energy as well as export of the energy. It also has the net metering capability. Net metering means it will give you the summation of total import and export at any point of time. So that means the net energy consumption at the household level will be provided. So 4-quadrant metering and net metering have the difference in the sense that 4-quadrant metering can provide import and export individually, while net metering will give you the net consumption or net export. Now it also has the capability for limiting the load in case of bad pay or for demand response purpose. Means if you want to disconnect the meter, the remote server can send command to the meter for disconnection. Energy prepayment. You can use a smart meter as a prepaid meter also. You can also utilize meter for power quality monitoring. You can use for temper and energy theft detection also. You can enable demand response program with the help of smart meter. It enables advanced metering infrastructure. We will discuss in detail. It supports various communication protocols such as ZigBee, Wi-Fi, WiMAX, GSM, GPRS and Ethernet. So Wi-Fi, WiMAX, GSM, GPRS and Ethernet are the most commonly used protocols for data communication. ZigBee is the data communication mechanism developed specifically for small packet data communication, and it is utilized extensively in the smart meter data communication. So when we will discuss the smart grid communications, we will discuss about the ZigBee protocol. Now it is easy to see power usage breakdown using a smart meter that helps in billing correctly under the multiple part tariff regime. So if you have time of use tariff implemented, since the smart meter data can be recorded at a regular interval, say every 5 minutes, then the effective billing can be done using time of use tariff also. It has a capability to store real-time energy usage information for a longer duration. Suppose if there is a communication network breakdown, it can store months of the data in its memory, so that whenever the communication network is restored, it can send data back to the server. It supports two-way communication, means it can send and receive signal from the meter. It supports remote connect disconnect. If consumer is not paying energy bill, it can send command to remotely disconnect the power supply. It communicates with other intelligent devices also in home to get consumption data of individual smart appliances as well. So for that, it interacts with smart home controller and gets the real-time information of the energy consumption from various smart appliances. Now let's talk about the evolution of smart metering technology. So till 2005, we were having the analog meters mostly. From 1990 to 2005, there was a time period where we started automatic meter reading, which was mostly monthly and one-way communication. It also offered temper detection and load profiling. Then you can consider the period between 2006 to 2008 as AMR plus, or you can say as second generation of smart meter, where the daily or on-demand meter read was enabled. We were having capability to read hourly interval data also, plus outage notification and other command reads. Then the third generation of smart meter enabled the advanced metering infrastructure, which offers full two-way data communication. This includes integrated service switch for connect disconnect, time-based rate, that is time of use tariff, integration, remote meter programming. You can remotely program the meter for any service, power quality monitoring, and house area network interface. Now, what is the need for smart meters? For customers, it helps to encourage customer to be participative in the energy conservation. It helps customers in saving their energy bills by shifting some of their energy from peak loading condition to off peak loading condition, which enables the demand side management. For customer, it is also required the real-time energy usage information such as alerts, status remotely, or you can get this information through your mobile device or maybe internet browser. So to address this requirement, the smart meter deployment is required. So smart meter also helps customer from any penalties due to non-compliance by informing it timely. Say suppose if the load sanctioned for a particular house is 5 kilowatt and the consumption breaches 5 kilowatt, meter will immediately alert you to reduce the consumption to save any penalty which will be imposed by the utility for overdraw. Now, why the smart meter is required for utility? It helps utilities to implement the time of use tariff, that is time of use pricing mechanism. It helps utilities in implementing incentive schemes for customers who maintain the power factor or participate in the demand side management. It helps in providing the remote connect disconnect feature for utilities so that without physically accessing the premises, they can remotely disconnect the power supply if required. It saves manual meter reading and billing cost because lot of effort are required monthly by the utilities to go door to door and read the meter data for billing purpose. So this saves a huge cost to the metering utilities. It reduces energy theft also because you can do the customer profiling, you do the customer segmentation, and if there is any sudden change in the consumption pattern of the customer, you can further check the customer energy consumption and see whether if there is any energy theft or not. It enables the real-time monitoring and control required for demand response program. So in this case, since the meter is sharing data almost in real time with the utility, utility can effectively implement the demand response program. It helps utilities in power outage management because before customer informs utility about any power outage, the meter itself will send signal to the utility that there is a power outage. And if suppose there is a huge number of signals coming at the control center related to power outage, utility can easily figure out the possible area of power failure. Sometimes it can also figure out the point at which the power failure have happened, and this helps utility to effectively carry out the maintenance of any faulty equipment of the power distribution system. So it reduces the overall operation and maintenance cost because lot of human intervention can be avoided for meter reading or for the meter disconnection or any fault identification or tracing of any fault and so on.